Unit 1, Part A, Basics of Computers. We're starting our course on computer security with a definition of computers and the components of computers. By defining a computer and defining its components, we also define the characteristics that we need to secure and the requirements that each component of a computer must meet in order to satisfy a security policy. Computers are composed of separate hardware and software components. Each component has a role to play in security and needs to work with the other components. What's a computer? Computers are data processing machines. They take representations of everyday events and process them as electronic bits and bytes. Data must enter a computer and data must leave it. All computers are ultimately some sort of electronic hardware. What makes computers different from their predecessors, adding machines, teletypes, cache registers, is the ability to program them using software. Data in, data out, hardware, software programmable, and computers have some sort of communication with the outside world. Many common devices are computers. Many devices have computers embedded in them. What we would all recognize as computers are, of course, the mainframes and servers that typically reside in a controlled data center environment, desktop systems, portable devices, laptops, cell phones of all sorts. Even the most basic cell phone has a microprocessor in it, and tablets. Printers are also computers. They're very sophisticated devices with processing units, programming languages in effect, storage, and network capabilities. Phone systems are computers. Both the more contemporary voice over IP systems, where even the handset is in effect a computer, as well as some of the older analog private branch exchange systems where the handset may not be very sophisticated, but the machinery behind it managing the phone system is a small computer system. Computers control factories, industrial control devices, buildings, heating, venting, air conditioning, etc. And they control your automobile. A modern-day automobile consists of multiple computers controlling the various systems that run it. Retail point-of-sales devices are no longer just a basic cash register, but are sophisticated devices for recording transactions and reporting them up to a central office. Entertainment devices, games, video players, music players, as well as devices for making entertainment are all computers as well. Components of a computer. A computer consists of multiple components, each of which must work with the other in order to provide the full value to a computer. Knowing what these components are, what they do, and how they interact with each other helps you determine how to secure the computer better. Computers, of course, underlying a computer is the hardware, the motherboard, the processor chip, the bus that conducts the data bits, the memory chips, the various plugs and connections that connect the board to the outside devices and so forth. This constitutes the hardware. And as we'll see in a later class, the processor chip itself actually has functions built into it to implement security policy. So in a sense, you've got security built in at the hardware layer. The operating system is a piece of software that communicates with and controls the hardware, manages the hardware resources. It abstracts away a lot of the difficulty of directly maintaining hardware and makes it a bit easier for human beings and other software to function without having to concern itself with the details of how particular disk drives work or how memory works, etc. Working alongside the operating system are device drivers. Operating systems themselves may contain software that talks to and manages communication with a lot of hardware, but in many cases you've got specialized hardware that requires software to run it so the operating system can recognize that hardware. Database management systems are software that accesses the file system that the operating system exposes and works with that file system to organize, manage, and maintain complex data structures. The operating system communicates with, say, a disk drive and exposes that disk drive's resources as a file. A database management system uses this file to then organize data into a set of linked tables. The operating system shell is a command interface that allows human beings to manage and maintain and work directly with the operating system. In the old days, this was something like the MS-DOS prompt, a basic command prompt for telling the operating system to do certain things. Most modern computing systems rely on graphical interfaces to manage the operating system and hence the hardware. Finally, the whole reason why computers are so common is application software. It's everything from a simple notepad document, simple text document, all the way up to an enterprise-wide enterprise resource management system like SAP R3 is all application software. The application software relies oftentimes on a database management system to organize its data for it, and certainly uses the resources of an operating system to access hardware resources that it requires. Hardware consists of a processor connected to various other devices, typically memory. The processor or CPU spends almost all of its time fetching instructions from memory and executing them. In modern computers, that memory includes both instructions for the processor as well as the data that the instructions work on, and maintaining the distinction between these two is very important for the sake of security. The CPU and main memory, however, are only two out of many components in a real computer system. Other components include the various storage and input-output devices. A computer system consists of many devices, typically organized by connecting those devices to one or more buses. A bus is a set of wire that contains or carries information or signals between components connected to those wires. They can carry data, actual data itself, addresses, locations within memory or within devices, or control signals, reminders and commands from one device to another to do something. An address directs the data to a particular device and perhaps to a particular register or location within that device. Control signals can be used, for example, by one device to alert another that there is data available for processing. And there goes a disk drive. Real PC software. There is more to an actual computer than a simple bus with peripheral devices attached. This diagram shows the basic hardware architecture of a personal computer. You've got the main CPU up there at the top with a front side bus, a very fast bus. You've got the North Bridge, which is a smaller processor, a computer in itself, which connects to the various high-speed conduits or buses to access memory as well as high-speed graphics card. And then connected to that via another bus is a South Bridge, which is another processor that's specifically dedicated to controlling slower, lower speed input-output devices, such as a keyboard, a mouse, other sorts of cables, maybe a USB port, etc. Now, the operating system provides a command interface or shell to the user, manages hardware resources along with device drivers. It manages processor resources, memory, disk resources, writes and reads, and the organization of the various hardware sectors of the disk into files, as well as potentially other devices. It manages these hardware devices through abstractions called processes, tasks, and users. And it provides programming interfaces or application programming interfaces to allow application software to use hardware resources. How should an operating system support security? By protecting its own executable code from illicit modification, by preventing modification or viewing of its own private memory areas, by protecting users' private memory areas from other users, and by enforcing system security rules and preventing the unauthorized bypassing of these rules. Here is an example of processes as they are managed by an operating system. The Windows Task Manager, for example, gives you visibility into some of these low-level processes that exist within the Windows operating system. Database management systems. They organize information logically. They allow applications to access data via standard interfaces, structured query languages, or SQL, so that the application itself doesn't have to concern itself with the internals of the database management system. It just says, get me this data, and the DBMS translates that into the right commands and provides the data. It permits end users to generate ad hoc reports. If you've ever used Microsoft Access to generate a report, you've got an example of that right there. And it enforces data consistency, because data that relates to real-world objects is very complex and has these interdependencies. And for the data to actually be valid, these interdependencies are required to be upheld and enforced, and a DBMS will do that for you. How should a DBMS support security? By protecting its data from modification using non-DBMS utilities. If it were easy for somebody to go in and just edit data using something that isn't a database management system, they could bypass the data consistency requirements or the access controls and violate the integrity of the data and make it absolutely worthless in many cases. By maintaining data integrity through mechanisms like commit rollback, referential integrity, etc., by ensuring that this complex set of interrelationships holds no matter what. By assigning access rights to the data consistent with the organization's policies, because the database management system organizes data into tables that consists of rows and columns, you can assign access rights to the table and to the rows and columns within those tables. And then by providing tamper-resistant audit logs of changes to critical data, so you have accountability for those changes. Application software provides end-user functionality. It's a reason why computers are so useful. It's because you've got applications on them. They can do things. They can track your finances. They can help operate your car. They turn on and off the air conditioning in buildings. They play music for you. This sort of functionality is provided by application software. This is why computers are useful to us. It organizes and manages complex data objects beyond that even, say, a database management system might be capable of managing. It enforces business rules. How should things be done? How data is entered, how data is managed according to rules that the organization wants to apply. Again, it's a step above what a DBMS does. They can handle more complex and yet more specific rules. How should application software support security? By supporting security functionality, such as identification and authentication of users to application functions, access controls governing user access to functions, and audit logs which detail the business transactions that a user may have conducted. By maintaining the reliability of the software itself through high quality, well-engineered design, by not failing, because software that fails, that crashes, it's not only that you lose the functionality of the software, but the failure of software provides an opportunity for an attacker to manipulate it. By assigning access rights to users consistent with the organization's policies. You see a pattern here of our operating system, DBMS, and now application software all perform similar functions but at a different layer, at a different level of complexity, and application software has its role there too. And by relying on the underlying database management system and operating system security measures.